Welcome to section 1.1 part 2. In my first set of problems, we're going to be multiplying radicals. It says to multiply using the box or the FOIL method. Okay, so what does the box method mean? You can choose. It kind of depends on which way makes more sense to you. If you're a visual person, you might prefer the box method. Or if you're comfortable with FOIL, then that's fine too. So let me show you how box method would work for this. I am a little cramped on space, but I'm going to see if I can get it in here. So I'm going to draw, I'm multiplying two binomials, meaning that there's two terms in the first set of parentheses, and there's two terms in the second set of parentheses. And it just means that they're separated by plus or minus. So I need a 2 by 2 box. Like this, okay. Across the top, I'm going to take the terms of my first binomial. So I've got 2 square root 3, I'll put here. And then 3 square root 5. On the left side, I'm going to put the terms of the second binomial. So 3 and negative square root 3. And then I'm going to multiply each row by each column. So the first square is going to come from 3 times 2 square root 3. Well, the 3 is on the outside, so I can multiply it with the 2. That would be 6 square root 3. Then I'm going to do the first row in the second column. This time 3 is on the outside, so I can multiply 3 times 3 is 9 square root 5. And then second row, first column. On the outside, I have 2 and a negative 1. So 2 times negative 1 is negative 2. Inside, I'm going to say square root. 3 times 3 is 9. And then in my last one, negative square root 3 and times 3 square root 5. So on the outside, it's going to be negative 3. And the inside is going to be 15. And I am really cramped here. That's negative 3 square root 15 inside there. Okay, so now we can write it all out. So looking at the inside, I've got 6 square root 3 plus 9 square root 5. Here I have minus 2 square root 9 minus 3 square root 15. Okay, can I do anything to simplify this? Okay, square root 3, square root 5, nothing I can do there. But square root 9, 9's a perfect square, so I can simplify that. So I'm going to bring this down. 6 square root 3 plus 9 square root 5 minus 2 times, and then the square root of 9 is 3. So I'm going to do 2 times 3, so that gives me minus 6. Minus, and here 15, if I do a factor tree for 15, that's 5 times 3, and I would need a number to appear 2 times before I could take it out. So that one's already simplified. Okay, looking at what I have left, in order to combine these, I need like terms. And remember, that means the inside of the radical has to be exactly the same, and none of these inside radicals are matched. So this answer actually is left with 4 terms, and that's as far as we can take it. Okay. All right, and now let's look at one of these over here on the right, simplifying quotients. Use a conjugate to rationalize a denominator. A conjugate means expressions that differ only in the signs of the second terms. For example, x plus y and x minus y are conjugates. Okay, so what we want to do, we don't want to have a square root in our denominator or a cube root or anything like that, because it's just yucky. You don't want that. So we want to be able to write this fraction so that there's no square root in the denominator. The trick is to multiply the top and the bottom by the conjugate of the denominator. What is the conjugate of the denominator? Okay, well, it's the same thing that you see, except you change the middle sign. So we want to multiply the top and the bottom of this thing by 4 plus the square root of 3. Okay, and I'm going to put parentheses around everything, because it all has to get multiplied. You might need a little extra space here to do this one, because we really are going to be doing 2 boxes if we do the box method. So on the top, we're going to do 2 plus square root 3 times 4 plus square root 3. I'm going to have to go to the side and have some scratch work, okay? So I'm going to come on a separate sheet over here. This is going to be my scratch work, and I'm going to label it scratch. I want to start with a box. And I want to do 2 plus square root 3 times 4 plus square root 3. And I think I did it, yeah, I think I kind of changed it doesn't matter which one goes on the side and which one goes on the top, as long as you've got, like, these are both on the same, so the 2 and the square root, so I apologize, I wasn't consistent there. But you could have done 2 square root 3 on the top, 4 square root 3 on the side, that's fine too. Okay, but we're gonna go through, we're gonna 2 times 4 is 8. 2 times square root 3 is just simply 2 square root 3. 4 times square root 3 is just 4 square root 3. Nothing more I can do there. Square root 3 times square root 3, well, that's the square root of 9. And that can be simplified. Okay, so my numerator, I'm going to write it over here, put an arrow, draw a line. My numerator is 8 plus, actually, let's write it out here first because we can simplify it. So we've got 8 plus 2 square root 3 plus 4 square root 3 plus square root of 9. But what's the square root of 9? That's just 3, right? So this is just, we can just say this is 3 here. We don't have to write the radical. 8 plus, all right, the middle 2 are like terms, so we can add that and say that's 6 square root 3 plus 3. And now we see we've got an 8 and a 3. They're constants. They can be added together. So now it becomes 11 plus 6 square root 3. That goes in my numerator. Okay, 11 plus 6 square root 3 can go right here. Sorry, I forgot my white out. All right, let me rewrite it over here. 11 plus 6 square root 3. Okay, and I am using an ink pen. That's only so that it shows up in the video really clearly for you. You definitely should be using a pencil so that, like, you can just see, everybody makes mistakes and has to go back and erase. All right, so in the denominator, what's going to happen here? What happens when you multiply conjugates together? Well, those radicals will magically disappear if we've done everything correctly. If you're multiplying 2 conjugates that have a radical, when we go through this process, we should not have a square root in our denominator after this. So let's go ahead and set up our box. Okay, 4 and negative square root 3, 4 and positive square root 3 goes on the top and the sides. Okay, 4 times 4 is 16. 4 times negative square root 3 is negative 4 square root 3. Square root 3 times 4 is 4 square root 3. And then square root 3 times negative square root 3 is negative square root of 9. So we'll write it out, 16 minus 4 square root 3 plus 4 square root 3 minus square root 9. But the square root of 9 is 3, so we can just say 3 here. So we have 16. All right, these middle 2 terms, they're like terms and they're opposite signs, so they just give us 0. And then we've got minus 3 over here. And 16 minus 3 gives me 13. So that denominator is 13, and it does not have a square root anymore. Really cool how that works. So that's what happens if you multiply conjugates together. Any square roots will go away. So you have a negative 3 in your denominator. And we're going to leave it just like that for now. Later you learn how to simplify it a little bit more, but that's fine for now. Okay, and I'm going to stop there in this video. So we will practice some more on these in class. Thank you.